acid and alcohol OH. If it's centered more around 3000, maybe a little bit lower, and it's more V-shaped, then it's going to be the carboxylic acid. So the OH group bonded to the same carbon as the carbonyl. Right. So the only other peak that you might see is the NH2. Now, just drawing out a rough sketch. The NH2 peak usually comes in roughly, I think, I don't have the data table with me, but it's generally at quite a high absorbance, so up past generally where the alcohol is. So if I draw just the far left hand side of the graph, alcohol might come in around here. I think it's around 3,700. And what makes it really, really obvious, it comes as a pair of peaks. So you don't just get one peak, you get a pair of them, forming a shape a bit like this. And sometimes maybe a bit pointier than that. But they're right next to each other. They're up at pretty high wave number. You'll very, very rarely see them, but they are on specification. They are on the data table. And this is one of the bits that you won't get from the data table. It won't tell you that there's a pair of peaks. It will just say that it's centered around 3,600 or 3,700. But it always comes as a pair of peaks if it's an NH2. If it was an NH, which is far rarer, then it would be a single peak rather than two peaks joined together. Right, that is basically the run through of how to interpret those spectra. We've got your key peaks. Oh, actually, I've forgotten one. I've forgotten one very important one, which is the C double bond. So, the C double bond. The C double bond typically comes in at just over 1600. I think it's about 1600 to 1650, so it's quite close to where the carbonyl peak might come in. Now, if I draw, so we've got our fingerprint region, got a bunch of messy stuff in there. It's not a very strong absorbent. So all these other ones we've seen before, so the alcohol, the OH group, and the carbonyl, they're very strong absorbents if they go a long way down to the bottom. The alkene one is actually quite a weak absorbance, so it only goes down maybe to about around down here. But it's pretty much always a very, very sharp peak. So it's not broad at all. It's going to be very, very sharp and pointy. And at that sort of 1600, 1620 typically. So we'll say 1620 centimeters to the -1. Then we might even we've got our CHs. Let's say we've got an alcohol group as well. So you might overlook it because we've got this big old peak here from the alcohol OH, and this little one, it can be even smaller sometimes, maybe only down to around here, so maybe even smaller, so just a little tiny peak like that. So look out for it, be one of the things you're looking for. So spot that, that's going to be the CC double bond. So I've assigned this with the CC double bond to that peak here. So when I ask you to assign spectra in the worksheets, just label that peak there. I'd label this an OH group. That's not enough information because there's different types of OH, so I'm going to write alcohol. Other things I might look for, we've got the absence of the carbonyl. We've got nothing at around 1700, nothing there, so it isn't a carbonyl, and then these are just the CHs. Nothing interesting about that, doesn't tell me anything. And anything here I can't interpret. On your data table there are things below 1500. It is meaningless, it doesn't tell you anything useful. You're certainly not going to be asked to assign anything from that or to draw any conclusions from information that's in the fingerprint region. So this is just fingerprint. Not useful unless I have access to a database. Right, hopefully that is the introduction you need to be able to have a good go at the questions I'm going to set you. So I'll look forward to getting that work and I'll have a look through it for you.